Hey guys, here is the lesson from Wednesday and Thursday that we did in class in case you were absent or you just want to watch it to refresh yourself before your quiz. So we're talking about direct variation, and direct variation allows you to use this formula y equals k times x. And remember, k is just some number, so it could be positive, negative, a decimal, a fraction. We call k the constant of variation. And then if you look at this formula, y equals k times x, and if I asked you to solve for k, you would know that you would need to divide both sides by x. So if you wanted to solve for your constant of variation, you just take your y values and divide it by your x values. Now let's look at how we identify whether we have a direct variation or not from a table of values. So in example 1, we have the point 3, negative 21, 2, negative 14, and 1, negative 7. So we have to determine if our constant is the same for all of these numbers. So we're going to take our y values and divide them by our x values. So when we take negative 21 and we divide it by 3, we get negative 7. When we take negative 14 and we divide it by 2, we get negative 7. And when we take negative 7 and we divide it by 1, we also get negative 7. So, if you're noticing over here, my constant is the same for all three of these points. So therefore, I do have a direct variation. Even if just one of these k values is different than any of the other ones, it would not be a direct variation. So then you can tell me that k is negative 7. And if I ask you to write the equation, you take the direct variation equation, y equals k times x, and you take what k is, and you're going to substitute it in. So your equation would be y equals negative 7 times x. So make sure you understand that when I'm asking for an equation, I actually want you to substitute in for your k value. So in example 2, press pause, determine if it is or it isn't a direct variation, and then press play so that we can check our answer. So for us to determine if it is a direct variation or not, we need to determine what our constant of variation could be. So we're going to take our y values and divide them by our x values. So when I do these for these 3 points, you should know that 5/2 is not the same thing as 7/3, which is not the same thing as 13/6, so therefore this is not a direct variation. Since it isn't a direct variation, you cannot say what the k value is, what the constant is, and you also cannot write an equation. So now let's see how we identify a direct variation from an equation. So in example 3, we have the equation 2y equals 6x minus 8. And if we remember from the very beginning that direct variation equations have the form y equals some number k times x. So if we look at the equation that was given to us, right now we currently don't have just y equals, so we need to solve for y. So to get rid of that 2 in front of that y, we need to divide by 2. So that's going to give me y equals, and then you do 6x divided by 2, which is 3x, negative 8 divided by 2, which is negative 4. So now you need to ask yourself, is this in the form y equals some number times x? And I hope that you say that it's not, because it has this minus 4 at the end, so this is not a direct variation equation. Example 4 is a you-try problem, so everybody press pause right now and determine if this equation is a direct variation equation. So just like I said in example 3, you're trying to get the equation in the form y equals some number k times x, and right now I don't have just y by itself, so I need to get rid of this 6 that's in my denominator. So to get rid of the 6 in the denominator, I need to multiply both sides by 6. So that gives me y equals, and then 2x times 6 gives me 12x. And is this in the form y equals some number times x? And I hope you said yes. So that makes this a direct variation. Since it's a direct variation, you can determine what k is, and k is the number that's in front of your x, so it has a value of 12. Okay, so let's learn how to solve for different variables. So in example 5, it says, suppose that y varies directly with x, and y is 15 when x is 3. What is y when x is 12? So I do this in 3 parts. The first part I do is, since it gave me this first part of my sentence, suppose that y varies directly with x, I can use the formula y equals k times x. So then if you look at this second part of this sentence, it says, and y is 15 when x is 3. So if I plug in my 15 and my 3, I am able to determine what my k value is. So I divide both sides by 3, and I get that k is 5. After that, I move on to step 2, where I write my new equation, y equals 5x. The reason why I do this step right here is most of the time when I give you a quiz, I'm going to specifically ask you to write the equation, so I want you to have time to practice it. So now, I can move on to the third part, which says, what is y when x is 12? So again, in part 3, if I substitute for my x value, I get 5 times 12, and I can easily find out that y is 60 when x is 12. The book is going to teach you to solve this problem by setting up a proportion. So when you set up a proportion, you want to have y over x equals y over x. And remember, you're making your k values when you do y divided by x. So if you did 15 divided by 3 equals, you don't know what y is, so that's what you're trying to solve for, divided by 12. And then you get to cross multiply. So let's multiply 15 times 12 together, and that gives me 180. And then we multiply 3 times y together, and we get 3y. Divide both sides by 3, and again you also get that y is 60. So I don't care which way you do this on a quiz, just make sure that you have all the work so I know that you know what you're doing. So example 6 is a you-try problem, and it says, suppose y varies directly with x, y is 20 when x is 2, what is x when y is 40? So solve for x, and then press play to find out if you got the right answer. So let's solve for k. So I plug in 20 for y, I plug in 2 for x, divide both sides by 2, and you get that k is 10. So my equation would be y equals 10x, which then allows me to substitute for y, so 40 equals 10x, divide both sides by 10, so therefore x equals 4. So now if you wanted to solve it based on your proportion, so you would put 20 over 2 equals 40 over x, because that's what you're trying to solve for, and then we're going to cross multiply, so 20 times x is 20x, and 2 times 40 is 80. Divide both sides by 20, and x equals 4. Example 7 is our last problem, and it's a word problem. So it says the calories in cheese varies directly with the mass. In 50 grams of cheese, there are 20 calories. Find how many calories are in 70 grams of cheese. So let's break it down by sentence. The calories in cheese varies directly with the mass. This is the same as the sentence in the other two examples where it says, suppose y varies directly with x. So based on that statement, I know I should be using this formula, y equals some number k times x. But right now I have no idea what y and x stand for in this problem, so let's read the first sentence again. The calories in cheese varies directly with the mass. So I am going to use C for calories and M for mass. Now let's substitute in 200 calories for 50 grams. Divide both sides by 50, and you find that K is 4. So I know that this problem does not ask us to do it, but let's write the equation, substituting in for our K values, so C equals 4M. And then we can go ahead and move on to our last step, and so C equals 4 times 70. You get 280, and then make sure you're answering the problem correctly. We are talking about a word problem, and it's asking for how many calories.